be easier to understand by examining a specific example. A 7th grade math teacher designed a rubric to assess the ability to solve problems with 4 operations with rational numbers and to use mathematical language. One of their practices is going to be shown here in its first draft form. Let's see if we can refine it using the 6 points that I just described. First, let's read it over as it stands. Not enough evidence says, I did not attempt to use arithmetic operations to start forming a solution to the problems. Beginning says, I can use arithmetic operations to start forming solutions. Developing, I can solve low complexity problems containing arithmetic operations. Proficient says, I can solve low and medium complexity problems containing the 4 operations. I can solve most problems containing the 4 operations and provide proper reasoning for some problems. Advanced says, I can solve problems containing the 4 operations and provide proper reasoning for my solutions. So that's their rough draft. Let's critique it. This is a great example of the process. It's so hard to shift our mindsets from content to skills, from specific to general. We all have years of training as both students and teachers to be evaluative and content driven. The first thing that stood out to me is the specificity of arithmetic operations. In this course, or if they intend to use the rubric over multiple years of schooling, will students be learning other types of operations? Most likely, yes. So you could change this to mathematical operations to be more general. For example, every place where arithmetic operations is, simply change those words and add for this unit to be sure that students are demonstrating knowledge of relevant material. In this way, I would be able to use this learning progression all year or even over multiple years, simply addressing new content. Reading over the beginning level, I question, what does it mean to start forming solutions? I think that the reflex action for most kids is to just get an answer. So if that's what students do, let's acknowledge that by stating to generate an answer, because that's what they will be doing anyway. And it's not wrong to try to answer the question. I would also want to emphasize that the student has agency. They have to make the choice of mathematical operations from whatever toolkit the teacher has supplied. For striving students, the teacher can even supply a list of those functions, allowing for easy differentiation. But still, at the very first level, students must choose what to do. So I would change use to choose. At the developing level and above, I'm concerned about the low and medium complexity issue. Why is this a problem? Well, the fact is that we consider low to be bad. If you really want to distinguish that, I would change low to foundational. Secondly, do students know what makes a problem foundational versus complex? Foundational might mean a single step versus multiple step problem, or it could mean that the function is given overtly versus having to interpret a word problem. In my experience, if a student can solve 5 plus 2 equals what, that's in order to be able to solve something like, there are 5 girls and 2 boys in a classroom, how many total students are there? In that perspective, the drill and practice of solving problem after problem is analogous to memorizing vocabulary in a Spanish class. It's the content, the medium used to do things. So what do we do with mathematical functions of all types? We solve word problems of increasing complexity as we progress through the grades. I think it's more useful, and again, I stress that I'm not the classroom expert here, but I would continue to maintain that students have to choose the correct operation to use in that context. I think that's a crucial step in this problem-solving process, knowing whether to add, subtract, multiply, or use some other operation. But where in the beginning they choose regardless of right or wrong, in developing they have to correctly choose. Continuing this thought, at the proficient level, they would now build on this correct choice and solve the problem correctly. I would change the word proper for relevant, because it doesn't have to be correct, but should be at least in the ballpark, using vocabulary about the problem at hand, etc. I would have to be sure to clearly define the word sum. Is there a minimum? An easy fix for this is to add when appropriate, so that you have the freedom to use this to assess a single question or a few but not all, and so on. Lastly, at the advanced level, we can now specify advanced complexity. By default, that means low and medium complexity is what we're dealing with at the other levels, so that doesn't have to be overtly stated anymore. We've already gotten rid of the low-medium terminology, but instead of saying advanced complexity, I would write multi-step problems. And of course, at this level, it should be correct. So here's our newly edited learning progression. How do we know if it's any good? Well, the best way is to check to see how this would work with a simple problem. If I asked a question such as, there are 5 girls and 2 boys in a classroom, how many total students are there? Is the floor low? A beginning level achievement only requires that the student chooses a function and solves it. That doesn't have to be the right function or the right answer, they have to try. So if the student writes 5 minus 2 equals 3, they've earned beginning. They chose the subtraction function and generated an answer, 3, to that problem. Wrong function and therefore wrong answer. Note that in this case the arithmetic was done correctly. 5 minus 2 is indeed 3, but we aren't scoring that according to this rubric. Note also that you could, by changing the beginning level statement to generate a correct answer based on the chosen function, you could give that feedback, but that's not what this group did. Now look at developing. If their response is 5 plus 2 equals 8, they have correctly chosen the operation and generated an answer even though they made an error. Oh, great job choosing the function. Now let's just practice the math facts together and you can easily move up to proficient, because here proficient is where the student is correctly solving. Note that on this particular question, the student could not earn advanced because the problem does not require multiple steps. The teacher can choose to ask a question like, there are 5 girls and 2 boys in a classroom and the same number of students in 2 more classrooms. If all 3 classes go out for recess, how many total students are there on the playground? You can use that problem instead of the original and still use the same rubric, scoring all students on where they land. Did they treat it like a single-step problem or a multi-step problem? And there are many ways to show work for this problem. Are any better than any others? How could you incorporate that information into this rubric? Maybe that's an argument for a 6th level expert. So we've refined this rubric to address generalization as well as descriptive language. A third issue that comes up deals with quantity. Remember at the start, the proficient level mentioned some problems? It can be tempting to say, list 2 reasons or list 5 reasons or use words like some versus many. This is not recommended as it can trap you and the students into quantity versus quality. In most cases, it's much more useful to deal with quality. I often distinguish between listing, mentioning, describing, and elaborating with specific details. This is where it's useful to refer back to the verbs list from Bloom's taxonomy. We altered that part to read, provide relevant reasoning for problems when appropriate. This leaves the teacher flexibility to specify how many are expected to be done on the individual assignment. The teacher might have students provide reasoning for just 1, or just the odds, or none at all. But those instructions would be on the assignment description, not on the rubric. Let's talk some more about the adding reasoning component. We already added flexibility by adding the words when appropriate. However, using this rubric, what if the student can solve multi-step problems easily, but neglects to provide reasoning? They will earn developing. I mean, that's okay, but that's got to be a conscious choice. For me personally, I think generating explanations is a separate skill from solving functions. I mean, I could imagine plenty of examples where I would want to generate an explanation without a problem to solve, maybe after examining someone else's solution or looking at a graph. So I would pull that out entirely and make a separate learning progression for that. That will eliminate the need for repetitive criteria later. So changes to eliminate quantity issues and help students flesh out the quality that we are looking for. I did not provide any explanation. I explained why I answered the question or solved the problem in the way that I did. Developing would be I used terminology from this unit in my explanation. Proficient would be the explanation includes overt definitions, laws, theories, or concepts. And advanced might be the explanation is correct even if my problem has a mistake. Again, we don't specify quantity here as the assignment itself will take care of that.